And now I'm going to talk about t-test with an example. So remember, t-test is done when you do not have a population standard deviation. So let's go ahead. So the t-test in the calculator, if you're entering data, again, this is very similar to z-test. Oops, not that, but that. So you're going to go to stat. You're going to go over to to test, and you go down to number 2 for t-test. It looks very similar to what we saw before. So your input is your either data or stats. For this, if you're entering data, you want it to be flashing. And then your next one is your population mean, then your list, then your frequency, and then you pick your alternative hypotheses. So what is it going to give you for your output? Your output for that is going to be, the first line is the alternative. The next is the t-test statistic. The next is the p-value, then sample mean, sample standard deviation, and then sample size. So what if you're not entering data? Well, you're going to do the same thing. You're going to go to stat, over to test, go down to here and hit enter. And then all you do is scroll over to here and hit enter. And then it gives you different things. It gives you population mean, sample standard deviation. Since you don't have the population standard deviation, you have to do the sample standard deviation, sample size, and then your alternative. So let's go ahead right fast and do an example. So statistics students believe the mean score of their first statistics test is 65. A statistics instructor thinks that the mean score is higher than 65. He samples 10 statistics students and obtains the scores, as you see. He performs a hypothesis test using a 5% level of significance. The data are assumed to be normally distributed. Okay, so let's go and let's see some stuff. So he believes that it is higher, right? That the mean score is greater than 65. So I'm assuming that's going to be our alternative right there. So let's go ahead and fill in some stuff. Is this test a one mean or a proportion? It's a one mean because we're dealing with averages again. And like I said in the slide before it, let's talk about our hypotheses. Your null, your mean equals 65, and your alternative, your mean is greater than 65. So C, is this a right-tailed, left-tailed, or two-tailed test? It's a right-tailed because of that greater sign right there on the alternative. What symbol represents the random variable for this test? That is capital X bar. In words, define the random variable for this test. The average score on the first statistics test. All right. Is the population standard deviation known? If so, what is it? We don't have a population standard deviation. It was not given to us, so we have to run a t-test. All right. The next thing, say, calculate the following. Well, what I'm going to do is I'm actually going to go into the calculator. Oops, let me go and put this on. And if you see here, I entered my test scores earlier. So I have all my data in there. So then I'm going to go to stat. I'm going to go over to test, down to t-test. I'm going to click on data because I have actual data in there and I want to see it. I wanted to see it and to pull it. My population mean is 65. Again, that is the mean that is coming from the hypotheses. So I have list as L1, frequency is is 1. So the alternative hypotheses is greater than. So then I go scroll on down, hit calculate, and what does it give me? So it gives me my sample mean of 67, you see it here. Sample standard deviation, which is 3.1972, I rounded up, and that's from the problem. And then my sample size is 10. So I answered all that stuff. Let me go ahead and spell deviation right here. Okay. And this didn't come from the problem. This actually came from the calculator. I don't mean to confuse you. So, all right. So the next step, which test should I use? It's a t-test because the population standard deviation isn't known. This has a different distribution. This has the t distribution. And the way you do t is t based on the degrees of freedom. So for this one, it's T9. And why is that? Because the degrees of freedom is the sample size minus 1. And up here, you see that N was 10. Okay? So let's keep going. So if I go back up to my calculator, I can see my p-value of 0.0396. So I put it right here. So I need to start making my decision. So I'm going to look at my p versus my level of significance, 0.0396. Is that less than 0.05? And it is. So because this is less than that, I reject the null hypothesis, and I say it here. So then, because I reject my null hypothesis, that means I'm keeping my alternative, and I can say at the 5% level of significance, there's significant evidence to show the mean test score is more than 65. This is a lot like what we did with the z-test. It's just we're not using a population standard deviation. There's very slight differences, but not a lot.